To the left or to the right?
To the left.
Yes, because the mean is smaller than the median. Okay, finally, and then we'll start working in MyLab Math. Very good. So that's how we create a box plot, the modified one. Okay, perfect. You can save everything, so you can go back and look at it. So here it is, something that I would like to discuss. I will post this, of course, after class. So let's look at the first one in the middle. See what happens? This is a symmetric bell-shaped distribution, and the mean and the median. So this is the median. The box plot does not present the mean. Okay, only quartile 1, median, and quartile 3. So we see that the two sides are balanced. The whiskers are balanced in the sense that they have the same length. This is our situation that we had a few minutes ago. Obviously, this is skewed distribution. Obviously, a longer whisker to the left and to the right. And that's by comparison. And obviously, the mean is further to the right. The median will be further to the left. And the same thing on the other side. The mean will be further to the left. The whisker on the right will be longer. And this is a distribution that is skewed right. Okay, any questions? This is the end of chapter 3. And now I'm ready to share my screen again. So I have no idea. I think I can close all these. No, I don't want to close that. Definitely. Okay. Okay. Ready. So please choose from 3.4 anything you would like to look at. And then 3.5. Preview. Anything you would like to work with or start with? Go ahead.
You can go ahead, Gabe.
Anyone? Any questions that you may have? Which one? Sorry, I talked at the same time and I couldn't hear you.
I said question 6.
6 it is. Okay, perfect. The table shows population statistics for the ages of best actor and best supporting actor winners at the end of the award. Okay, the distribution of the ages are good. I'm going to copy those. So that's my page 6. And we are working on, which number is this? 6 and 3.4. Okay, perfect. So I have mu1, 45, sigma 1, 6.8, mu sub 2, 49, sigma sub 2 is 12. So this is for best actor and best supporting actor. Fine. Okay, the best actor was 62 years old and the best supporting actor was 47. So here we have 62 and here we have 47. This is x sub 1 and this is x sub 2. Determine the z-scores for each. Okay. Can anyone give us any ideas?
Well, the x value would be the years old in like the equation.
Yes.
And then you would subtract that from the mean and divide it by the
It's the other way around. It's x1 minus the mean divided by sigma.
Yeah.
Okay, perfect. So we have 62 minus 45 divided by 6.8. And I'm waiting for Preston to give us that number. And then Z2. Yes?
Did you say my name? I'm sorry.
Yes, I would like you to give us this number, please. And then the other one will be, as you said, 47 minus 49 divided by 12.
Did the math in the notebook. I think I did the math in my notebook.
Who would like to give us the other one?
I got the other one. It's 4.083.
4.083, and the first one?
Got. Sorry.
Alex, do you have the answer for us? Alex? Mara, do you have the answer for us?
I got 2.5.
Okay, we'll see in a moment. Round to 2 decimal places as needed. So here we want to enter 2.5. Where is my keyboard? Right here. And here we want 4.08. Let's see. Okay. So
That last one,
yes. If you don't put parentheses, 62 minus 45, close the parenthesis and divide by 6.8. That's correct. If you don't put parentheses, divided by 12.
negative 8.17. The last one, I think.
So 47 minus 49 divided by 12 is negative 0.17. 47 minus 49 divided by 12. Okay, so minus 0.17. So using the calculator, if you do not put parentheses, I'm not sure how you calculated that, but just be careful. Okay, the best actor was, okay,
More than 2.
More than
Above.
2 standard deviation above, which is
Unusual.
It is unusual. More than 2.5 is unusual. So let me stop sharing for a second. Remember what we said about the Z distribution. Z distribution has 0 right in the middle, negative 1, 1, negative 2, 2, and this person is somewhere out, right here in the tail, in the upper tail. So this is unusual. Okay. So back to sharing. The best supporting actor was
Less than
below.
1.
I agree. Which is or is
Not.
not unusual. We all agree. Very good. Excellent. Well done. Next question.
14.
You said 12?
I did, but if you want to do 14, you can.
We'll do both. Let's do 12 and then 14. That's fine. So 12 and then 14. Okay. So during 1 year, there were 10 hurricanes recorded. Their maximum wind speeds in miles per hour were as shown in the following table. Consider these storms a population of interest. Fine. It says a population of interest. Okay, we'll see. Obtain the following parameters. Okay, so that is the population because they're saying parameters. Or the maximum wind speeds. For the maximum, okay. Use the appropriate mathematical notation for the parameters to express your answers. Okay, so we want, so this is problem, we chose problem 12 in 3.4. Okay, so we want part A, we want the mean. In part B, we want the standard deviation. And then we want the median. And we want mode. And we want the interquartile range. Fine. So let's click on this. Good. So let's go to data stats. Summary stats with columns. Please choose the wind. Yep. And I'm going to choose, if I can, only those, but for some reason it doesn't work for me. So we want mean, standard deviation, median, mode, IQR. So that's the mean. Standard deviation. Okay, well.
Are you holding down control?
Yes. Yeah, for some reason. Okay, let me do it again. Mean. Okay. Standard deviation. We want the median. We want the mode. The mode is at the bottom. And we also want the IQR. So mean, standard deviation, median, mode, and IQR. Compute. Excellent. Okay, so the mean is 98.5. The standard deviation, 18.1123. I don't know how many decimal digits they want. The mode, multiple modes. The median, 97.5. And the IQR, 25. Now, the only question I have, and I want to convince myself before we put those answers in, whatever they are asking us. I'm just going to copy the data in a list in my calculator, this particular data set. So I have 90, and then 100, and 110, and 75, and 105, and 75 again, and 125, and 85, 95, 125. Do I have 10? Yes, I have 10. And then do a one variable stats with list L1. Okay. So the mean is indeed 98.5, the standard deviation 18. Okay, so I'm convinced now that there is a problem. Okay, so let me explain the problem. We'll see in a moment if I'm correct. See, the standard deviation is calculated by StatCrunch as the sample standard deviation. Be very careful. But we are told that this is the entire population. If the data set is the entire population, I have to use sigma. I cannot use S. So be careful. So what I need to enter is 17.1828 because we are specifically told we are dealing with the population, not the sample. So
I think if you're taking the standard deviation of the population, you do the unadjudicated one.
Yeah, that's what I used for the homework.
Which one?
In StatCrunch, you can go to the statistics, like the sample stats or whatever it is, and there's a if you go to stat and then summary statistics and then columns like we always do. If you scroll down in there, there's a unadjusted standard deviation. And
excellent. That's what I need. That's what I need. Very good. Okay, and that should be exactly what I just determined. I'm going to check. Yes, exactly. 17.1828. Excellent. Thank you. Great job. Okay, so now we're ready. The population mean is represented by this symbol and is equal to
17.1.
careful 98.5. Type an integer or decimal, do not round. The population standard deviation is represented by, okay, I called on Mara and she didn't answer. Hold on. Ethan, are you here? Ethan, are you here? Okay, Madison, are you here?
Yes, I'm here.
Can you please tell us what is the symbol for the population standard deviation?
Would it be? It's not the mu, is it? Well,
We can hear you.
Okay. I was saying that I'm a little bit confused on B, so I was listening to what you guys were saying.
Okay. Anyone else would like to help?
Is that very
It-
bottom one?
Isn't it like the circle with like the little line above it? I don't know how to describe it.
Sigma.
Sigma?
Very
yeah.
good. Okay. The population median, okay, we have it, is 97.5.
You did enter the value for the standard deviation.
Oh, I didn't. Yes, thank you. So it's it says around to 1 decimal place. So that's 17.2. Careful. Find the mode. What would you say?
It's 75 and 125.
So there is no mode.
There is mode. Did
There's
you hear her?
multiple.
Multiple modes. Okay.
So Emma said that it's
Oh, yeah.
75 and 125.
Sorry, I don't know if you heard me, Professor.
Okay. I'm sorry. I may have not. So 75 and 105.
125.
125. Thank you very much. And the IQR was determined to be 25. Excellent. Good. Now we want to look at 14. Let's look at 14. Very good picks. Well done. Okay, use the accompanying data set to complete the following actions. We want the quartiles, the interquartile range, and identify any outliers. Okay, perfect. Very good pick. Thank you. So I'm on my page 7. Okay, so this is 14 in 3.4. Perfect. So they want Q1, Q2, Q3. They want the interquartile range and outliers. Perfect. So here it is. Wake up, wake up, wake up. Good. So stats, summary stats, columns, variable 1. Okay, my keyboard. We want Q1, Q2, Q3. Okay. Q1, Q3. Oops, I didn't mean that. I want the median. I want the interquartile range. Where are you? Here you are. Okay, perfect. And compute. Yes, you can find the outliers by simply looking at the box plot if that's what you want, but I would like us to determine them by hand first. So I have Q1, 58. I have the median, 61. I have Q3, which is 64, and I have the interquartile range, which is 6. So I'm going to stop sharing for a second. So I have to determine the upper fence and the lower fence. Okay, so this is Q1, Q3 plus 1.5 interquartile range, and Q1 minus 1.5 the interquartile range. Someone who have not heard from today, like Michael, Adriana, Vi.
What was the question?
Determine the upper fence and the lower fence. And you have the formula.
Alright, I can figure it out real quick.
Good. Excellent.
Upper fence is 9.
The upper fence.
Give me a second, sorry.
The
73.
Very good. Awesome.
73.
Excellent. 73 indeed. And what about the lower fence?
The lower fence is 49.
Very good. The lower
Yeah, that's
fence.
what I had as well.
Excellent. Great job. I love it when we work together. That's the whole purpose of any class. Please work with me. First quartile, we said 58. Then the second quartile, We said 61, or the median, the same thing. And the third, 64. Then the interquartile range, it already gave it to us, is Q3 minus Q1, where the 50% of the observations lie. Identify any outliers. So the 73 is way above.
So 77 is one of the outliers.
So I
It's
should,
above the
yeah, I should have, where is my, I should have determined also the min and the max, right? So the minimum, maximum. So the minimum is 56 and maximum is 77. So min 56, max 77. Thank you. Great job. So since the maximum is 77 and the upper fence is smaller, there is no outlier up there to the right. But the lower fence, and the lowest fence is 49 and minimum is 56, so there is no. Everything is between the upper fence and the lower fence, so there is nothing outside of that. So did we determine?
Isn't 77 the
Oh, 77. It was 77. Yes, it is. That's true. Thank you. It wasn't intentional.